In this week's episode of BSD Now, we have DragonflyBSD 5.4. Down the Gopher hole with OpenBSD we go. OpenBSD also in stereo. We cover VFIO in this one. The BSD OSs are the best candidates for legally tested open source Unixes, apparently. And OpenBGPD adds diversity to the routing server landscape in this week's episode of BSD Now. BSD Now, episode 275, OpenBSD in stereo. Recorded on the 5th of December 2018. Hello, I'm your host, Benedict Reuschling.
And I'm Alan Jude.
And as winter is almost upon us, depends on where you are listening to this episode, we have headlines as always in this week's episode, starting with a good news because DragonflyBSD 5.4 has been released. And they have, of course, release notes.
Yep. So Dragonfly 5.4 comes with a number of big ticket items, including updating the system compiler to GCC 8, improved NUMA support, so that's non-uniform memory access. That's when you have something like a high-end Intel machine or the new AMD machines where there are actually multiple separate packages or complexes for those processors, the memory is attached to only one of them. So, if you have a dual socket system, often you'll have two banks of RAM, one attached to the first processor and one attached to the second. Accessing the RAM on the opposite processor from a process running on the first processor will be slightly slower, and so on. And so NUMA allows the operating system to understand this and try to give you memory that's lower latency from where you're going to run the program. Yep. That especially becomes important as you get with these newer AMD machines where you can have 4 or 8 and more domains instead of just 1 or 2. Plus, they have a large number of network and virtual memory driver updates and updates to their video support.
Ooh, great. Oh yeah, and remember this release is 64-bit only, as with the previous releases, so get to that architecture if you aren't there already.
A bit more detail on the NUMA stuff. In particular, this provides much better support for asymmetric NUMA. So that's where maybe you have a different amount of RAM in those 2 different banks or 4 different banks of memory. I know that was an interesting problem came up that FreeBSD was having at EuroBSDCon, where somebody had a machine where one of the sticks of RAM was bad, so they took it out. But that meant that one zone had like 64 gigs of RAM and the other zone only had 32 instead of 64, or 48 instead of 64, something like that. Had like 16 gigs less RAM. And so in the default policy of round-robining allocations, that would cause that one to be full while the other ones were empty and start causing really strange failures. So they say, in particular, both the memory subsystem and the scheduler now understand the Threadripper 2990WX's architecture. The scheduler will prioritize CPU nodes with directly attached memory, and memory subsystem will normalize memory queues for CPU nodes without direct attached memory, which improves cache locality for those CPUs. They've also done incremental performance work. Dragonfly as a whole is very SMP friendly. The type of performance work we're doing now is mostly revolving around improving the fairness for shared versus exclusive lock clashes and reducing cache ping-ponging due to non-contending SMP locks, such as the massive use of shared locks on shared resources and so forth. Mm-hmm. There was also a major update to dports that brings them up to within a week or 2 of the FreeBSD ports tree. In particular, the major update includes Chromium and lots of stuff for GCC 8. There was also a major rewriting of the TTY CLIS code and the TTY locking code, which provides significant improvements for concurrency across multiple TTYs or PTYs. Mm-hmm. And like we mentioned, they brought GCC 8.0 as the default compiler now, and GCC 4.7.4 and 5.4.1 are still installed. 4.7.4 is the backup compiler, and 5.4.1 is still there to ensure a smooth transition, but should generally not be used because the build world builds all three by default to ensure maximum compatibility. And then they have some improvements to HammerFS. So Hammer 2 is recommended as your default root file system now in its non-clustered mode. Cluster support is not yet available. They've increased the bulk free cache to reduce the number of iterations required for freeing space. They fixed numerous other bugs, improved support on low memory systems, and did significant pre-work on the XOP API to help future networked operations.
Mm-hmm.
And
interesting
instructions on upgrading and a summary of all the other changes, including fixes for CVE 2018-8897, the debug register issue, the full spectrum mitigation support, changes to the default permissions on the /root directory. In collaboration with OpenBSD, they've completely removed the delayed floating point state to avoid the known side channel attack. So switching from, was it lazy FPU to eager FPU or whatever?
Mm-hmm.
And that includes proactively zeroing the user registers on entry into the kernel, such as a syscall interrupt or an exception, to avoid speculative side channel attacks. They also updated their DRM, the graphics driver support, to match Linux kernel 4.7.10. And the Radeon driver has been updated and currently matches Linux 3.18.
Okay.
And then
yeah, this seems
lots and lots of other smaller fixes.
Yeah, this seems like a worthwhile thing to upgrade to or try out if you have some time after the holidays or during, maybe. So yeah, DragonflyBSD, congrats on a new release. And yeah, if you have interesting use cases for that or are using it and have some interesting stories to tell, send it to us at feedback@bsdnow.tv. So next item goes down, way down, down the Gopher hole with OpenBSD, with Gophernicus and TLS. So this was interesting enough for us to include it, and goes like this. So in the early 2000s, the author of the article here thought it had seen the worst of the web. Java applets, Macromedia, Adobe Flash, animated GIFs, JavaScript snow that kept you warm in the winter by burning out your CPU, and so on. For a time, we learned from these mistakes and started putting the burden on the server side. Then with improvements in JavaScript engines, we started abusing it again with JSON and Ajax, and it all went downhill from there. Like cloud computing, blockchains, machine learning, and a ton of other a la mode technologies around today, most users and service providers don't need websites that consume 1 GB of memory processing JavaScript and downloading 50 megabytes of compressed data just to read Alice's one-page travel blog or Bob's notes on porting NetBSD to his blood pressure monitor. Excellent use cases. Yeah, but it gets better. So before the HTTP web, we relied on Prestel/Minitel style systems, BBS systems, and arguably the most accessible of all, Gopher. Gopher was similar to the locally accessed Amiga guide format in that it allowed users to search and retrieve documents interactively with links and cross-references. Its efficiency and distraction-free nature made it attractive to those who are tired of the invasive, clickbait, ad-filled, JavaScript-laden Web 2 or 3.x wherever we are. But enough complaining and evangelism. Here's how to get your own Gopher hole. So here's Gophernicus. You can see a screenshot, of course, and is a modern Gopher daemon which aims to be secure. Although it still uses inetd, it's even an OpenBSD port, so at least we can rely on it to be reasonably audited. So if you need a starting point with Gopher, SDF-EU's wiki has a good article that's linked here in the notes. And there is information, of course, how to get that, how to configure it. And In this one, they have S-Tunnel in use, but at the beginning of the article, they mentioned that they are now have updated the support to add TLS to it. But they are not quite sure about the polishness, if you can say that, about the code. They don't recommend it yet for production use, but you can still take a look. And they, so finally, if you don't like Gopher, there's always Lynx or NCSA Mosaic way back when. Oh yeah, those were the days. You can find the link there in the cryogenics web. And they've added TLS support, as I mentioned. And so this is definitely something for the security-minded folks to have. And yeah, definitely check it out if you want to have some nostalgia or less burden on your CPU and memory just by rendering some web pages.
Yep. Although there's one thing I would mention, I don't think OpenBSD audits all the software in their ports tree, only the base system. So just because it's in OpenBSD ports doesn't mean it's audited. But
yeah, otherwise they would be very busy, as they are already.
Well, also, and that the ports tree probably couldn't contain Firefox or Chromium or, LibreOffice or anything like that. But anyway, that's cool.
So, heading right into the news roundup this week, we have more OpenBSD news. OpenBSD in stereo with Linux's VFIO.
Yeah.
That's important.
So we have a blog post here from Joshua Stein who says, I use a Huawei MateBook X as my primary OpenBSD laptop, and one aspect of its hardware support that has always been lacking is audio. It never played out the right side speaker. The speaker actually works, but only in Windows and only after installing the Realtek Dolby Atmos audio driver. Under OpenBSD and Linux, and even Windows with the default Intel sound driver, audio only ever played out of the left speaker. Because Atmos is fancy. It's their theater quality sound ported to your home type thing.
But
a friend of mine has it in his media room.
But from multiple speakers, I would think.
Yes,
not just
and
from
so
the
I think
left.
it's emulating. So with Atmos software, you basically make that effect somehow with fewer speakers. Anyway, so now after some extensive reverse engineering and debugging with the help of the VFIO people on Linux, I finally have audio playing out of both speakers. Stereo. So VFIO. The Linux kernel has functionality called VFIO, which enables direct access to the physical device, like a PCI card, from user space, usually passing through an emulator like QEMU. To my surprise, these days it seems to be primarily by gamers who boot Linux, then use QEMU to run a game in Windows, and use VFIO to pass the computer's GPU device through to the Windows VM. By using Linux and VFIO, I was able to boot Windows 10 inside QEMU and pass my laptop's PCI audio device through to Windows, allowing the Realtek audio driver to natively control the audio device. Combined with QEMU's tracing functionality, I was able to get a log of all the PCI I/O between Windows and that PCI audio device. So rather than being content to just have audio work in a Windows VM, they used QEMU to watch what the driver was doing to the device and then reverse engineering it.
Oh.
So to use VFIO to pass through a PCI device, it first needs to be stubbed out so the Linux kernel's default device drivers don't attach to it. So grub can be configured to instruct the kernel to ignore the device. So you give it the this vendor and card ID, and explicitly enable the Intel IO MMU driver by adding it to your grub and running update grub. With the audio device stubbed out, so that it doesn't get attached by the host OS, just like setting the, I think it's PPT dev setting, if you want to pass through a device in Beehive on FreeBSD. So now the new VFIO device can be created from that device. So when the VFIO device is created, we can then pass that to QEMU. I was using my own build of QEMU for this due to some custom logging that was needed, and more on that a bit later. But the default QEMU package should work fine. Then events.txt is a file of all the VFIO events I want to have logged. Since I'm frequently killing QEMU and restarting it, Windows wants to go through its unexpected shutdown routine each time, and would sometimes even fail to boot. To avoid this and to get a consistent set of logs each time, they use QEMU image to take a snapshot of the image first, and then boot from exactly the same snapshot every time. That way Windows would always be starting in a consistent state. So now they have QEMU logging everything it's doing to the audio device. So with a full log of the PCI I/O from Windows, I compared that to the output from OpenBSD and tried to find the magic registrar writes that enable the second speaker. After days of combing through the logs and annotating them by looking up hex values in the documentation, diffing runtime register values, and even brute forcing it by mechanically duplicating all I/O in the OpenBSD driver, nothing would activate that right side speaker. One strange thing I noticed was if I boot Windows 10 in QEMU and activated the speaker, then booted OpenBSD in QEMU without resetting the device, both speakers worked in OpenBSD, and the configuration that the HDA controller presented was different, even without any changes to OpenBSD. So if the device had already been switched to a certain mode by running the Windows VM, just booting OpenBSD, it would detect it differently and it would work. So a quick primer on the Intel high-definition audio driver. Most modern computers have integrated sound chips that use the Intel high-definition audio codec, with one or more other codecs like Realtek's ALC269. These codecs do the actual audio processing and communicate with DACs and ADCs to send digital audio to the connected speakers, or read analog audio from a microphone and convert it to a digital input stream. So on the MateBook 10, this is done through the Realtek ALC298 codec. On OpenBSD, these HDA controllers are supported by the Azalea driver, with all of the per codec details in the lengthy Azalea codec.c file. This file is growing quite large with lots of codec and machine-specific quirks to route things properly, toggle the right GPIO pins, and unmute speakers that are, for some reason, muted by default. The Azalea driver talks to the HDA controller and sets up various buffers and walks the list of codecs. Each codec supports a number of widget nodes, which are interconnected in various ways. Some of these nodes can be configured on the fly to do things like turning a microphone port into a headphone port, and so on. On the MateBook, which was released just a few months ago, it was also plagued with this speaker problem, although it has 4 speakers and only 2 work by default. A fix is being proposed for the Linux kernel, which just reconfigures these widget pins to let the Intel HDA driver do it. Unfortunately, no pin reconfiguration is enough to fix the MateBook with its 2 speakers. While reading more documentation on HDA, I realized there was a lot more activity going on than I was actually able to see with the PCI tracing. For speed and efficiency, the HDA controller uses a DMA engine to transfer audio streams as well as commands from the OS to the codec. In the output stream, they have a bunch of different registers and so on. The command output ring buffer and the response input ring buffer each have 256 entries. The HDA driver allocates a DMA address and then writes it to those 2 base registers, and again, then does the reads. When the driver wants to send a command to a codec, such as codec get parameters, with the parameter, say, volume node capabilities, it encodes the codec address, node index, and command verb, and the parameters, and then writes that value to the ring buffer at the address set when we initialize things. Once the command is on the ring, it gets a PCI write to the write register, which advances by 1. This lets the controller know a new command is queued, which it then acts on and writes the response to the other ring buffer for the OS to read back from. It then generates an interrupt telling the driver to go read it. Since the actual command contents and responses are handled via DMA writes, these important values weren't showing up in my tracing. So, did a little hacking to QEMU to log the DMA as well. So, with the custom hacks to QEMU, added some HDA awareness to remember the addresses of the input and output ring buffers. Anytime a PCI write to the register is done, QEMU fetches the new values of those buffers from the DMA memory, decodes those into the codec address, node address, command, and parameter, and prints it out. So when a PCI read of the other register is requested, QEMU reads the response and prints that as well. With this hack in place, I now get a full log of all the input and output commands being sent to the HDA driver or device. So an early version of this patch left me stumped for a few days because after submitting all the correct commands in OpenBSD, the second speaker still didn't work. It wasn't until I reread the spec that I realized that the Windows driver was submitting more than one command at a time, writing multiple commands to the buffer and writing a value that advanced by 2 or 3 or however many commands, telling the driver, hey, there's 4 commands for you to go do. So this required changing the hack in QEMU to use a for loop to go that many commands instead of just reading the first one. This way it would read every command or response instead of only the first one in each set. Sure enough, the magic commands to enable the second speaker were sent in these periods and were being missed in my first pass of debugging. So now that I know everything that the driver is sending to the device, now I have to minimize that down to just what do we have to do to actually make it work. The full log from VFIO from Windows driver was 65,000 lines, and there were 3,150 commands sent via DMA, which is a lot to sort through. It took me a couple more days to reduce that down to a small subset that was actually required to activate that second speaker, and that could only be done through trial and error. So boot OpenBSD with a full list of the commands, comment out a group of them, compile and install and restart, suspend and wake the laptop to reset the PCI power to the audio device, which would reset the Dolby initialization and ensure the previous run hadn't influenced the current test. Because, once you get it kind of working, then you won't be able to tell if your change made it work more or didn't have any effect. You also is sure there's a better way to reset the PCI power than to suspend and resume the laptop, but it worked, so he did that. Anyway, start up QEMU, boot OpenBSD, and play an MP3 file, and that alternated between right and left channel, and listen and make sure sound comes out both channels. So this required dozens of iterations, or maybe only 1 or 2 dozen, because sometimes I comment out too many commands and the right speaker would stop working. Other times, the combination of commands would hang the controller and I wouldn't process any further commands until he reset it again. At one point, the combination of commands actually flipped the channels around so the right audio came out of the left speaker. So that was confused. But in the end, we have results. So after about a week going through this routine, I ended up with a list of 662 commands that are needed to get the second speaker working. Based on the number of repeated but slightly different values with the 0x500 and 0x400 commands, I'm guessing there is some kind of training data, and that is done, it's doing basically a full Atmos system initialization, not just turning on the second speaker, but I could be completely wrong. In any case, the stereo sound from OpenBSD is wonderful now, and I can finally stop downmixing everything to mono to play only from that left speaker. In case you ever need to do this, the SND IOD can be run with -C 0:0 to reduce the channels to just 1. Due to the massive size of the code required for this quirk, I'm not sure if I'll be committing it upstream to OpenBSD or just saving it in my own tree, but at least now the hardware support chart for my matebook is all yeses and for all the things I care about. I've also updated the Linux bug report that I opened before venturing down this path, hoping one of the maintainers of the HDA code there that works at Intel or Realtek maybe knows more about this and could make a smaller fix that maybe could be committed to OpenBSD.
Okay, that would be beneficial to multiple people. So yeah, definitely a lot of effort just to get the audio on both. I remember getting my first sound card and it was like, ooh, no more PC speaker. I have real sound and voices even if they had, but that was a long time ago. Okay.
Yeah, my first computer had a Sound Blaster
Pro?
No, I think it just
there were a couple of models.
Plain.
Yeah.
I don't think
But
it was
still.
a Sound Blaster 16. I forget. I don't know. It was a 46. It was pretty advanced.
Okay, yeah.
Eventually,
So
the problem was that it had a compact QVision 1 megabyte video card, which eventually started being not enough to play games.
Yeah, because some of these sound cards even had a game coming with them in the package.
Sometimes, and they often were the only way you got a game port to connect your joystick to.
Yeah. Oh yes, those were the days. Yeah. But back to the show. We have our second item here in this segment is why BSD/OS is the best candidate for being the only tested legally open Unix. So this is over at Virtually Fun and starts with the Unix system is an old operating system, possibly older than many of the readers of this post, including me. However, despite its age, it still has not been open sourced completely. In this post, they will try to detail which parts of this Unix system have not yet been open sourced and focus on the legal situation in Germany in particular, taking it representative for the European law in general, although this is a stretch knowing the diversity of European jurisdictions. And please note that familiarity with basic terms of copyright law is assumed. So yeah, this might be a bit legalese heavy, but we'll get through. Okay, so first, Ancient Unix. The term Ancient Unix refers to the versions of Unix up to and including 7th edition Unix from 1979, including the 32V port to the VAX. Ancient Unix was created at Bell Laboratories, of course, a subsidiary of AT&T at the time. It was later transferred to the AT&T Unix Support Group, then AT&T Information Systems, and finally the AT&T subsidiary Unix System Laboratories, Incorporated, the USL. The legal situation differs between the United States of America and Germany. In a ruling as part of the Unix Systems Laboratories Incorporated versus the Berkeley Software Design Incorporated, USL versus the BSDI, famous case, a US court found that USL had no copyright in the 7th edition Unix system and 32V. Arguably, by extension, all earlier versions of Ancient Unix as well, because USL/AT&T had failed to affix copyright notices and could not demonstrate a trade secret. And due to the obsessive tendencies of U.S. courts to consider themselves bound to precedents, like the infamous Pearson versus Post case, it can be reasonably expected that this ruling would be honored and applied in subsequent cases. Thus, under U.S. law, Ancient Unix can be safely assumed to belong in the public domain. And so here, the situation differs in Germany. Unlike the US, copyright never needed registration in order to exist. Computer programs are works in the sense of the German 1965 Act on Copyright and Related Rights, henceforth Copy A. And as per copyright paragraph 2, section 1, number 1, even prior to the amendment, this is a super legalese text, to include computer programs have been recognized as copyrightable works of the German Supreme Court. And the paragraph 137D rightly clarifies that. The copyright holder at 1979 would still have been USL versus Bell Labs and AT&T. Copyright of computer programs is transferred to the employer upon creation under Copyright Act, paragraph 69. Note that this does not affect expiry, and there's another case listed there. So the expiry, or the expiry occurs 70 years after the death of the co-author or the author that died most recently as per the Copyright Act paragraph 65 and 64. This has been the case since at least 1960s, meaning there's no way for copyright to have expired already. So, but definitely Germany, private international law applies to the so-called Territorialitätsprinzip. Only I can say that. It's the territorial principle, basically. That's what it says. For intellectual property rights. So this means that the effect on the intellectual property right is limited to the territory of the state, and additionally, in the oh dear, that's a super old word. The Schutzlandprinzip, the protect the land, or the principle to protect the land. I don't know. It's not a very common word in Germany nowadays, probably in legal terms. But this principle applies, and this means that protection of intellectual property follows the lex loci protectionis, like the law of the country for which protection is sought. So if you want to copyright something in a country, then that country's law applies to that. Although it's criticized in parts of doctrine, and that principle required that the existence of an intellectual property right be verified as well. So, thus, in Germany, copyright on ancient Unix is still alive and well. Who has it, though? A ruling by the U.S. Court of Appeals, 10th Circuit, in the case of the SCO Group versus Novell, another famous or infamous case, in the U.S. made clear that Novell owns the rights to System 5, thus presumably Unix System 3 as well. And ancient Unix, though SCO acquired enough rights to develop Unixware/Open Server. Novell itself was purchased by the Attachmate Group, which was in turn acquired by the COBOL vendor Microfocus. You're still following? Okay. Companies buy each other, and confusion happens after a while if you don't track that too closely. So therefore, the rights to SVRX and outside the US are with Microfocus right now. And if you care about this, if the
only thing you care about is the US, you can stop reading.
But it's difficult because it's not just the US, it's international. How does the Caldera license factor into all of this? For some context, the license was issued January 23rd, 2002, and covers ancient Unix, version 1 through version 7, including 32V. Specifically, excluding System 3 and System 5. Caldera was founded in 1994. The Santa Cruz operation, SCO, sold its right to Unix to Caldera in 2001, renamed itself to Tarantella Incorporation, and Caldera renamed itself the SCO Group. Nemo plus Juris ad alium transfere protest. Here we're going to Latin now. Yeah, here we go. I need to have a firm talk with JT for picking that article. So now the question becomes whether Caldera had the rights to issue the Caldera license.
Right, because that bunch of Latin means that no one can transfer rights that they don't actually have.
Yeah, I cannot give anything that I own. So I've noted it above, but it needs restating. Foreign decisions are not necessarily accepted in Germany due to the Territorialitätsprinzip. You should, cut at that point and just let me repeat this all over again, like a ringtone or something. So Territorialitätsprinzip and the Schutzlandprinzip. However, it will be citing a U.S. ruling for its assessment of the facts that for the sake of simplicity. As per ruling 10-4122, the district court found the parties intended for SCO to serve as Novell's agent with respect to the old SVRX licenses, and the only portion of the Unix business transferred outright under the APA, the Asset Purchase Agreement, was the ability to exploit and further develop the newer Unixware system. SCO was able to protect that business because it was able to copyright its own improvements to the system. The only reason to protect the earlier Unix code would be to protect the existing SVRX licenses, and the court concluded Novell retained ultimate control over that portion of the business under the APA. And the relevant agreements consist of multiple pieces, of course. I won't go into those as well.
Yeah, so skip down to the BSDOS section.
Yeah, because that makes people wake up again. So the BSDOS part of this is that another operating system near Unix is of interest. The USL versus BSDI lawsuit includes two parties. The USL, which we have seen above, and Berkeley Software Design Incorporated, BSDI, sold BSD/386, later BSD/OS, which was a derivative of 4.4 BSD. The software parts of the BSDI company were acquired by Wind River Systems, whereas the hardware part went to IX Systems. You might have heard about the latter one. So, copyright is not disputed there, though Wind River Systems ceased selling BSD-OS products 15 years ago in 2003. And in addition, Wind River System let their trademark on BSD expire, though it is without consequence for copyright. So, BSD-OS is notable in the sense that it is powered, or that it powered much of early internet infrastructure. Traces of its legacy can still be found on Richard Stevens' FAQ. And to truly make Unix history free, BSD-OS would arguably also need to see a source code release. BSD-OS has, or at least in its early releases under BSDI, would ship with the source code, though under a non-free license, far from BSD or even GPL licensing. So System 5 here, the fate of System 5 as a whole is difficult to determine. Various licenses have been granted to a number of vendors. Dell Unix comes to mind, HP for HPUX, IBM for AIX, SGI Unix, etc. So Sun released OpenSolaris. Notoriously, Oracle closed the source tool Solaris again after its release, which is a System 5 Release 4 descendant. However, this means nothing for the copyright or licensing status of System 5 itself. Presumably, the rights with System 5 still remain with Novell, or now Microfocus. SEO managed to sub-license rights to develop and sell Unixware/OpenServer themselves to System 5 or 3 descendants to Unixis, oh dear, now known as Xinuous Inc., which implies that Xinuous is not the copyright holder of System 5. Is your head hurting now? Well, it's the same for all of us. Okay, so obviously to free Unix, System 5 and its entire family of descendants would also need to be open sourced. However, I expect tremendous resistance to parts of all the companies mentioned. And as noted in the Ancient Unix section, Microfocus alone would probably be sufficient to release System 5, though this would mean nothing for the other commercial System 5 derivatives. And newer research Unixes, the fate of Bell Labs would be a different one. It would go on to be purchased by Lucent, now part of Nokia. After commercial Unix got separated out to USL, Research Unix would continue to exist inside of Bell Labs. Research Unix version 8, 9, and 10 were not quite released by Alcatel-Lucent USA and Nokia in 2017. However, this is merely a notice that the companies involved will not assert their copyrights only with respect to any non-commercial usage of the code. It is still not possible over 30 years later to freely use the version 8 code. Yeah, so in conclusion, in the US, Ancient Unix is freely available. People located everywhere else, however, are unable to legally obtain Unix code for any of the systems mentioned above. The exception being BSD-OS, assuming a purchase of a legitimate copy of the source code CD. This is deeply unsatisfying, and I implore all involved companies to consider open sourcing, preferably under a BSD-style license, their code older than a decade, if nothing else, then at least for the sake of historical purposes. And the author here would like to encourage everybody reading this to consider teaching or reaching out to Microfocus and Wind River Systems about System 5 and BSD-OS, respectively. Perhaps the masses can change their minds. And a small note about patents. Some technologies used in newer iterations of the Unix system, in particular the System 5 derivatives, may be encumbered with software patents. An open source license will not help against patent infringement claims. However, the patents on anything used in historical operating systems will certainly have expired by now. In addition, European readers can ignore this entirely. Software patents just aren't a thing. Oh, wow. Yeah. Okay, that's that's the history of companies buying each other and licensing and sub-licensing, and that's where we are today.
Luckily, FreeBSD is free, and we don't have to worry about this so much.
For a reason, yeah. And yeah, it took effort to get there, and the legalese had to be done, or the parts that required court cases, I guess, were somewhat necessary. But we can now enjoy it as freely as we can. Okay.
So next up, we have OpenBGPD adding diversity to the route server landscape. So RIPE NCC, which is the group that administers IP networks and so on in Europe, and thanks to their community project fund, we're able to revive the OpenBGP daemon and bring more diversity to the route server landscape. So as of last year, there was effectively only a single solution for a route server on the vendor market, and that was Bird. Nick.cz, the organization that developed Bird, has done a fantastic work on maintaining their BGP4 implementation. However, it's not healthy to have virtually every internet exchange point in the world, especially those in the NCC or RIPE NCC service region, depend on a single open source project. The current situation can be compared to the state of DNS root name servers back in 2002. Their dependence on the bind name server daemon resulted in the development of NSD by NLnet Labs in cooperation with RIPE NCC. So, OpenBGPD used to be one of the most popular route server implementations until the early 2010s, when OpenBGPD's main problem was that its performance couldn't keep up with the internet's growth, so it lost market share. An analysis by Job Schneiders suggested that the modernization of OpenBGP would make a viable option to regain diversity in the route server market. So they first had to look at missing features and the problems. So the following main missing features were identified. First was performance. In previous versions of OpenBGPD, the filtering performance didn't allow proper filtering of all external BGP sessions. Current best practices for Internet Exchange Point route servers is to carefully evaluate and validate all routes learned from external peers. The OpenBGPD rule set required to do correct filtering in many deployment scenarios was simply too lengthy and negatively impacted service performance during configuration reloads. While filtering performance is the biggest bottleneck, general improvements to the route information base were also made to improve scalability. The IXP route servers with a few hundred peering sessions are commonplace, and adding new sessions shouldn't impact the route server's service to other peers. We found that performance was the most pressing issue that needed to be tackled. But also, there was the lack of RPKI origin validation. As we've seen, internet operators are moving to adopt routing PKI-based BGP origin validation. While it was theoretically possible to emulate the RFC 6811 style origin validation in previous versions of OpenBGPD, the required configuration wasn't optimal for performance and wasn't user-friendly. We believe that BGP origin validation should be as easy as possible. This requires BGP4 vendors to implement native optimized routines for origin validation. Of course, enabling origin validation shouldn't have any impact on performance, either when processing BGP updates or when updating the route origin authorization table itself. Other issue was portability. OpenBGP is an integral part of OpenBSD, but IXPs may prefer to run the service infrastructure on the operating system of their choice. Making sure that there's a portable OpenBGPD version, which follows the OpenBSD project's release cycle, will give IXPs this option. So, development steps. By adding the issues mentioned above, by addressing the issues mentioned above, we could bring back OpenBGP as a viable route server. Since I was one of the core OpenBGP developers previously, I was asked if I wanted to pick up the project again. Thanks to funding from the RIPE Project Fund, this was possible. Starting in June 2018, I worked full-time on this important community project. Over the last few months, many of the problems have been fully addressed and are now part of OpenBSD 6.4. So far, 154 commits were made to OpenBGP during that development cycle, around 8% of all the changes that have ever happened in OpenBGPD. This shows that due to funding and dedicated resources, a lot of work could be pushed in the latest version of OpenBGPD. So this latest version of OpenBGPD, which is part of OpenBSD 6.4, demonstrates great progress. Even though there has been many changes to the core of OpenBGPD, the release version is as solid and reliable as previous releases and has many bug fixes and improvements that make it the best OpenBGPD release so far. The changes in the filter language allow users to write more efficient rule sets, while the introduction of our PKI origin validation fixes that provides an important missing feature. For internet exchange points, OpenBGPD is now an alternative again. There are still open issues, but the gap is closing. So they introduced a background soft reconfiguration on config reload. Running the soft reconfiguration task in the background allows new updates and withdrawals to be processed at the same time. This improves the convergence time, which is one of the key metrics for a route server. They have the BGP origin validation, fast prefix set lookups. In OpenBSD 6.3, prefix sets got introduced into OpenBGPD. A prefix set combines many prefix lookups into a single filter rule. The original implementation wasn't optimized, but now a fast try lookup is used. Thanks to this, large internet route server database prefix tables can be implemented efficiently. They also introduced AS sets, lets you group many autonomous system numbers into a single lookup. Thanks to this, large IRR database origin AS tables can also be implemented efficiently. And they added origin sets for our PKI stuff. They've also improved some third-party tools. Two open source projects such as BGPQ3 and a route server are frequently used by network operators and IXPs to generate BGP configurations. Thanks to our contributions to these projects, we were able to get them ready for all the new features of OpenBGPD. So BGPQ3 was extended to create the AS set and prefix set tables based on an IRR database. This is replacing the old way of doing the same with a large number of filter rules. Thanks to the quick response from the maintainers, it was possible to ship OpenBSD 6.4 with a newer BGPQ3 package that includes all of those features. And a route server was adjusted to implement the RPKI, ROA set, AS set, and prefix set, and origin set to generate the much better performing configurations for 6.4. With the release of 0.20 of a route server, IXPs are able to generate OpenBGPD configurations a ton faster, but also implement new functionality. If you look at YYCIX, which is an internet exchange point in Calgary, Canada, partly run by Theo Durad of OpenBSD, the rule set generated by a route server was introduced, so the rule set was reduced by 370,000 rules to just 6,000 rules thanks to the sets.
Ooh, wow.
This resulted in initial configuration time dropping from over an hour to less than 2 minutes.
That's significant.
And the subsequent configuration reloads are hitless and no longer noticeable. But there's still some more work to do. A sizable chunk of this work left on this table is to rework the RIB data structure in OpenBGPD that hasn't been changed since the initial design back in 2003. There's currently ongoing work in small steps to avoid jeopardizing the stability. To modernize these data structures, the goal is to provide better decoupling of the filter step from storing the RIB database changes and to pave the way for a multi-threaded operation. And I don't know what the status of the portable version is. I know a bunch of people that would love to get a newer portable version of OpenBGPD on FreeBSD.
Mm-hmm. Oh, yeah.
So looking forward, says it's been incredibly productive to create an environment where a core developer is allowed to work full-time on OpenBGPD. However, it's important to note that there's still room for a number of new features to be added, such as BMP, RFC 7313, add path, etc. It'd be beneficial to the internet community at large if we could extend Claudio's involvement for another year. Open source software doesn't grow on trees. Strategic investments are the only way to keep OpenBGPD's roadmap aligned with the internet's growth and internet operators' requirements.
Oh yeah, this is definitely
Yeah,
Good.
if you run an IXP, you should probably get in touch with Ripe or Claudio directly about funding more work on this.
Yeah, it's beneficial to you as well and the internet at large. So, time for Beastie Bits this week. We have a bunch of items here. Dragonfly, first thing, Git annotation here, tag 5.50 has been created.
Yep. Now that 5.4 is out, the 5.5 unstable branch is open.
Yeah, continue development and the stuff is being worked on. And yeah, get in touch, get involved if you're interested in the Dragonfly development.
Yep, there's an entire list of what each person changed. I'm definitely going to have to look at what Bill Yuan did there with IPFW.
Oh, yeah, yeah.
Yep. Next up, Charlotte from MeetBSD, if you remember, has got Torchlight 2 almost working on NetBSD. So if you like gaming on your BSD, you might want to check that out.
Yeah, if you have some free time coming up anytime soon. I can't recall when, but yeah, it could be. Yeah, spend some time in a good game. Next up is we have an older but still good Unix login article on Capsicum.
Yep.
So here's the link.
We've talked about it quite a bit lately, and I'm sure you recognize both of the people on here. Pavel Doedek, who did the original port of ZFS to FreeBSD and worked on Geom, wrote Geli and Hast, the audit DISD, and did a bunch of work on Capsicum. And his, I don't know if protege is quite the right word, but Mariusz Zaborski, whose blog we've been following and who's doing a lot of recent development on Capsicum. So this is their original Unix login paper about their work on that.
Yeah, well worth reading. If you want to know more about Capsicum or the story behind it.
Skipping around just a little bit out of order. Then the next thing we have is the Super Capsicumizer 9000.
If that is not an interesting name.
Right, so this takes John Anderson's lib pre-open, which he talked about at VBSDCon and BSDCan last year, year before that even maybe, which is basically, because of the way Capsicum works, once you enter the sandbox, you're not able to access the file system anymore. You can access file descriptors you already have access to, but you can't gain access to a global namespace like the file system to open more files. Now, what you can do is you can get a directory descriptor, a descriptor that lets you have access to a certain directory and open files relative to that. But that would require modifying, say, a Python program to know all these things. So what John did with the pre-open was basically a wrapper around the Python application that would know which files the Python application was going to need, open them ahead of time, so you'd have file descriptors for them. Then, as you run the Python program, when it tries to open those files, instead of getting access denied from Capsicum, you would just give it the file descriptor to the already opened file. And with this, John envisioned oblivious sandboxing, being able to sandbox an application without the application needing to be modified or aware of the fact that it's being put in a sandbox. And now a user has taken this library and gone further with it and modified, so not completely oblivious, there's a small patch, but GTK 3.24 has been modified so that you can run any GTK application. In their testing, they were using gedit under X11 or Wayland from inside a Capsicum sandbox.
Okay, very nice.
So all you need is a recent version of FreeBSD, the Mason build system, a new version of libucl, and a version of libpreopen. And with just a little bit of configuration, telling it what paths it needs access to, what libraries it might need, and other stuff you want to load. And then when you run it, it will run the application.
Ah, yeah, there's the screenshot.
Yeah, so this would allow your text editor to edit documents in the home directory and the temp directory, but not, go roving all over the file system or something.
Yep, good to have. And if they really,
as you can see in the screenshot, if you try to use gedit to edit something under /etc, you're told that no, you can't go there.
Forbidden. Yep.
That's cool. It's nice to see that happening.
Mm-hmm.
So next up, we have something I came across while looking for. I don't remember what I was looking for, but it's called KnockPS. And it's a provisioning system for data centers, and it's specifically designed to do Pixie boot to deploy OS and a bunch of other things, but it deals with a bunch of different bits, including supporting FreeBSD and most common flavors of Linux and Windows, dealing with power management, so it automatically can sort out and deal with your machine, whether it's using IPMI, something standard like the Supermicro IPMI, or HP ILO, or Dell DRAC, or whatever, or if it's got the newer Redfish HTTP implementation of IPMI, or Intel's AMT, or vPro, or if you have an APC, UPS, or power distribution unit that has remote reboot switch. It also supports IPLMIN, Cowcom, and Reactivity remote power switches, and the Telejet web resetter. Integrates with switches and routers and stuff for SNMP. Can hook up with rescue systems like sysrescuecd and Clonezilla. Hooks up to your billing system like HostBill or Blesta or your own via a PHP API. And it can deal with dedicated servers, VMware vSphere, Citrix Zen Server, or Proxmox. So this will take care of deploying and managing VMs and physical hardware all in one. And it has support for FreeBSD.
Excellent. Yeah, that's good to have with Pixie booting.
Mm-hmm. I'd like it if a couple more providers offered a BSD rescue system, kind of like MFS BSD or something, because sometimes when you need to fix your FreeBSD, you can't really do it from Linux because it doesn't have the right tools.
Yeah, to get to the real bits that are important.
Yeah, I can usually fix a Linux from a FreeBSD, but I can't fix a FreeBSD from a Linux.
Yeah. But yeah, other good news is that the Cirrus CI people have announced FreeBSD support. And they have a little guide here that's listed how you get started. And it's pretty straightforward. You edit your .cirrus YAML file. Remember, YAML file, you need to be careful with tabs, or actually not using tabs at all. And then you enter your instance type and what kind of tasks it should run. And they also list a couple of images, though they have a 12.0 RC3 image available, 11.2, 11.1, and 10.4 releases. Yep.
And it's basically just running on Google Compute Engine, and so it's good to go. In particular, they also mentioned that Cirrus CI, the company, provides free access for open source projects. And so there's that, or you can actually use their software to run your own as well.
Excellent. So yeah, great efforts from the CI, Cirrus CI folks, and yeah, that's appreciated. And more on the gaming front is that we have found a Twitter post here, or a link to a video showing NetBSD Pinebook gameplay. So that's
there's somebody playing a version of Doom on a Pinebook running NetBSD.
Who would have thought, back in the day, that this would run on a very little embedded computer? And
well, this is the Pinebook, so it's actually a laptop.
Oh, right. Yeah, the two. Yeah,
it's this big.
Yeah. Oh, yeah. $100
bigger than my head.
But still, yeah, it's good to have for a little gaming here and there.
Well, yeah, there's nobody had the concept of $100 computer when Doom came out.
Oh, yeah. How many people would have gone to computing if that was available back then?
Mm-hmm.
But yeah, okay, now we have it, and you can replay some old games. And important notice for all the BSD folks out there, BSD Can 2019, the call for paper is out.
Yes. So you can start today submitting for BSD Can 2019, which will be May, what's that, 6th?
It's on the website.
15th to 18th? Right. Well, Dan only listed the conference days, not the whole conference.
Yeah. Go to the home page. Then
you'll want to arrive by Tuesday night.
Yeah, Tuesday is the day where you should be there at the latest.
But the conference is Friday and Saturday. But you want to get there by Tuesday, trust me. Anyway, if you would like to submit a talk or a tutorial, because that's what happens on Wednesday and Thursday, you can now go start submitting right now. You have until January 19th. Don't wait for the last minute, please. It's hard on people that have to decide which talks to accept if they can't at least start reading over them until everybody submits 5 minutes before the deadline.
Yeah, look at the previous BSD Can schedules to see what kind of talks were there, like sysadmin types or development, kernel, ports.
All kinds of things like that. Other nice thing, because of the way the paper submission system works, you can go in there, submit what you have now, and go back next week and improve it, and go back the week after and improve it, and just get something in there right away, and then keep working on it.
Yeah,
it's important.
A good thing.
Yeah, and a tip I've given people a couple of times now when I ask, I don't know what to talk about. It's like, so it helps if you've been there before. In that case, on your first or second time there, what was the talk that you wanted to see that wasn't there? Or, what do you wish you knew a couple of years ago that you know now? Well, there's probably a lot of other people that wish they knew that a couple of years ago too. So
chances are, yeah, definitely give the talk that you didn't hear yourself.
Yeah, or the talk you wish someone had given you a couple of years ago.
Yeah,
that's how we bootstrap the next people. Yes, an architect who did his first conference earlier this year says that you should definitely practice your talk in front of a mirror and make sure it's actually as long as you think it is. I've seen many people where the talk ends up being much longer or much shorter than they ever planned it to be.
Yeah, don't run overtime or be shorter and have like half an hour left.
Yes, you definitely want to have a minimum of 35 minutes of talk and then some time for questions or whatever. Actually, BSD Can gives you basically the full hour, so you really want to have like 40-ish minutes and then time for questions. It often turns out if you think there will be a lot of questions, there are not. And if you don't think there will be any questions, there will be many.
Yeah. Or if you're the tutorial type of person, then you can also submit a tutorial for the 2 days before the actual talk.
You can submit both. Conference.
Yes, both work. Definitely give a talk and a workshop.
Yes.
On both days.
It actually marginally increases your chances because you're like, we'd only have to pay to fly this person once and we get 2 things out of them.
Wonderful, yeah. So think about something and don't forget the deadlines. So you have until January 19, 2019.
Yep.
That's easy to remember.
Then a month later, they will let you know whether you've been accepted or not. So you'll have plenty of time before May to get ready.
Yep. Okay, so you heard it here, and we cannot blame us for not telling you.
Yes, and I'm sure we'll remind you a couple more times, but hurry up. Come on.
But we should finish the show before you run off.
And yes, also, if you're not planning to submit, at least plan to attend. Let's make this 2019 should be the biggest BSD Can ever. We didn't break the record last year. We tied it. We need to get bigger this year. And that means just any one of you who is going to go but then didn't, it's your fault. You better make up to it this year.
Yeah. Yeah, we will keep nagging and you will be there. You can meet us and other people, for example.
It really is fun. One of the people who I nagged and came for their first time last year is now planning to try to go to Europe as well as Canada again.
What better way to get into the BSD conference spirit?
Yep. Oh yeah, and one random note, I guess, before we go on to the feedback, as I just realized, actually this morning, that an anniversary had passed, and I hadn't quite realized it. My very first ZFS pool turned 7 years old last week.
Ooh, okay. So when did you create that one? After the...
November 29th of 2011.
Oh, that's still early days for the FreeBSD port of ZFS.
So this was on 9.0 RC2, if I remember correctly.
Okay.
Because 8.4 had a much older version, or 8.3, I guess was what it was at the time. I don't know. The 8 branch had a much older version of ZFS. It was like V16 or something versus V28 on 9.0.
Mm. So how many disks died in those 7 years?
None.
Huh.
All 8 of the original Seagate 2 terabyte SAS drives are still working. 2 of them have a couple of defective sectors that have been remapped. So 2 of them are showing signs of old age. But that means 6 of them are still working perfectly.
That's
and they've been spinning continuously. And they were under heavy load all until early this year, 2018. The machine got repaved. Basically, the data that was on it outgrew the machine eventually, obviously, and moved to a machine that instead of 8 2 terabyte hard drives had 36 4 terabyte hard drives.
Yeah.
Yeah. So that data got migrated and the machine got reinstalled, but I purposely didn't
left the pool
rebuild the pool. I imported the old pool because it's my very first pool and I want to keep it around.
Yeah, it has historic value. I mean,
yes. At some point, those drives will just go on a shelf somewhere so I can connect them every once in a while and be like, here's my old pool from 2011. And look, it still works on FreeBSD 17.
Yeah, because we can import all those old pools again. Yeah.
Although actually, that pool's upgraded, right? So it's a modern FreeBSD 12 pool right now.
Yeah, not the original version. Yeah, because you wanted the new features.
It's been upgraded over time.
Mm-hmm. Well,
yes, if you want all the details on that original server and the fun times that were had with it, that's over in the TechSnap podcast back in like November of 2011 or so.
Oh, yeah, it's been a while.
It'd be like episode 30-ish or something, I think, was when I built that server. It was sat on my desk in my little apartment. I built it up because a fun time there. Originally bought it with an Adaptec RAID card because A, I didn't know not to use RAID in ZFS, and B, I believed Adaptec when the box says supports FreeBSD on it. And they provided a binary driver for FreeBSD 8, but I wanted to run 9. And
yeah,
it with some hacking, I got a driver and it worked. And then every once in a while, the controller would just go on vacation for 6 hours and then come back.
Here I am again.
It never lost any data, but it really wasn't good for performance when you couldn't get any commands to complete for 6 hours.
Yeah.
Luckily, what I found out is
vacation.
The motherboard had an onboard SAS controller that wasn't on the list of supported hardware in FreeBSD. But it turns out it was supported by 9, just not by 8. And so that was just a matter of pulling the SAS cable out of the Adaptec, plugging it into the LSI on board on the motherboard, and everything just worked magically.
Okay,
which was another of the features of using ZFS instead of RAID. If I had had a RAID 5 made with the Adaptec and then plugged those drives into the LSI controller, almost certainly would not have worked. I would not have just been able to do zpool import, get all my data back, and go.
Yeah, much easier for migrating between controllers. Yeah, give it an extra nice scrub from all of us, and more until 7 more years, if not longer. Okay, let's go right into the feedback and questions for this week. Again, if you have a question for us that we have for this segment, because otherwise this would be a very empty segment, send it to feedback@bsdnow.tv. Otherwise, we cannot help you. The first person who did the same thing to ask us a question is Malcolm about installing drivers in development. And the message goes, how does one install a driver that is in development? For example, there is an ATH10K driver being worked on, and my laptop uses that chip. The repo is just the driver code with a link below, and I'm compiling my kernel by hand already on the 12th branch. Do I just put the code somewhere in there?
In this case, yes. It has a source directory here, so that you put that, overlay that with user source, and it basically provides user source sys dev athp and contrib dev athp. So it provides all the bits you need. If you just overlay this source directory onto user source, it should in fact not overwrite any existing files, just graph the new ones in. And I think there might be a change to a makefile you might have to make to include the new directory, but in general, you would be able to start playing with it.
Yeah, and any kind of compiling errors you get, or when you get it running and you have some weird issues, then report that back to the author, because that is valuable feedback for the developers to fix those bits there.
In general, you will see this more as an actual fork of the full FreeBSD tree with just the change grafted in, and you'll be able to basically check out that branch, pull up the later FreeBSD on it, and integrate it that way. This one's a little different, but yeah, it's just a matter of applying those files to your tree.
Yep. So that should be
I don't know how close to working that driver is as far as how much luck you're going to have, but let us know.
Yep. Okay. That was Malcolm. And next up is Samir with Introduction to ZFS. And the question here goes, I've really been enjoying your podcast each week, and it's even gotten me to install FreeBSD and OpenBSD on a pair of old ThinkPads. Excellent. Great. So he's interested in learning more about ZFS. For someone who doesn't know anything more about how to spell it, what are some good introductory tutorials or resources to help me get started with it? Thanks again.
For ZFS, actually, the FreeBSD Handbook's ZFS chapter, which was mostly written by Benedict and myself, actually, a couple of years ago now, walks through a bunch of the stuff, including creating a test pool with just backed by files on your file system. Doesn't matter if it's ZFS or not, that you can then purposely break and then recover using scrub or resilver and so on. Or where you can silently damage it, watch it kind of work normally, and then try to read the file that was damaged and see ZFS detect that and either deal with it or at least give you an error instead of giving you back the gibberish. Whereas if you had just done a UFS file system and done the same damage to it, you might have just saw that same gibberish that you'd written rather than the file you expected.
Yeah.
So it walks you through all the basic stuff on how to create a pool, how to do the test pool, damage it, recover it, and so on, how to deal with a failed disk, how to deal with expanding the pool, all of the different things you need. Beyond that, obviously the FreeBSD Mastery ZFS book, which you can get from zfsbook.com, walks through all the basics of that as well in quite good detail. Other tutorials, the handbook's a good resource, and it's got a bit of a tutorial feel to it. It mostly comes down to, like most things in BSD and open source and so on, if you really want to learn it, you have to kind of come up with a bit of a project that you want to do, and then have more specific questions to that way.
Yeah, and don't be put down by the huge feature set that ZFS provides. You basically just need how to build a pool, how to create data sets, and then maybe look into how to create snapshots or maybe set
ZFS
quotas or something.
Was specifically designed to make dealing with disks easier. So you don't have to worry about partitioning really. You don't have to worry about, how big of a file system do I want to make? It's like, actually, I just put all my space together and use it as I need and add more when I run out. It really was designed to make things as easy as possible. So it, in the end, while ZFS can do all kinds of complicated things, you don't have to know about any of those to use it effectively. You can use it and be protected by it by just following the very, very basics, and then you can slowly learn more and more and go further and further.
Yeah,
I'm still learning, and I've been doing it for 7 years.
Yeah, but the handbook article or the handbook chapter has a bit of explaining to it and text around the examples, so you can try them out and also read upon what they actually do and what's supposed to happen. But yeah, using that on old ThinkPads is a good way of getting your feet wet into the area of ZFS and the BSDs in general. So that's good approach. Okay. Next and last for this week is Unix with, the dreaded drive failures. And it's a bit longer, but here goes. Heard you've been low on feedback recently, so I figured I'd send you in an issue that came up recently with a server running FreeBSD 11.1. Okay, I've been tasked with upgrading our NMS at work, or the network monitoring system. I've been using Zabbix 3.4, which has been great for the most part. It's fairly undocumented for BSD configuration. Since the initial server, an older ProLiant with dual Opterons and a frustrating RAID controller seems to have run into some drive issues, causing boot to fail due to issues importing zroot. I figured this would be a great time to ask about some ways to improve the system. First, I/O optimization. I've had a hard time finding much on the topic, but the drives are reporting 512 sectors, and the Postgres database is using 8K records. Should I set the dataset record size to be 8K as well? Is there some tuning you're aware of to improve the I/O for Postgres installs on ZFS?
Yes. So on the ZFS dataset that holds your actual data for Postgres, that should have an 8K record size. I think if you check the OpenZFS.org wiki, they have the other settings. I think for the write-ahead log, I think that one's supposed to use 128K separately than, or a different value than the actual databases do. So you'll end up with at least 2 data sets, possibly a third if you want like regular log files and so on. There are some Postgres tuning you can do as well, specifically telling Postgres that, hey, ZFS is going to take care of this, so don't do the double buffering and so on. You might just quickly check the Postgres mailing list. They have a bunch of stuff there. There's also a couple of presentations we've talked about before. I think one was at Nicebug, and there were a couple at BSDCan, and I think there was actually one at PGCon this last year, or both in 2018. That covers a bit more of that as well. But
the two that I have is setting synchronous _commit equals off, and the other one is full _page _writes equals off, because they are not needed on ZFS, but only on ZFS.
Yes, but maybe we should work with Thomas Monroe, who's a Postgres committer who recently became a FreeBSD committer, in order to make some changes to FreeBSD to make Postgres better. Work with him on adding a small subchapter of the ZFS chapter on tuning Postgres.
Yeah, there is one on the Postgres wiki. So this is wiki.postgresql.org/wiki/performance_optimization. And they have a bunch of articles for Postgres in general. And I think a couple of those will mention ZFS as well.
Yeah, but yes, you want 8K record size on the data set that's holding the actual databases. This is because Postgres writes changes to those in blocks of 8K. Well, if you do the default of having 128K record in ZFS, you're going to have to read the whole 128K off the disk, modify one of the middle 8Ks of it, and then write all 128K down again. Well, as you might know, writing 128K every time you change 8K is going to make the disk a lot busier than writing 8K every time you change 8K.
Yeah. Okay.
And in general, for databases, for the database part for for Postgres and MySQL, there's also a ZFS setting, redundant _metadata. If you change that to most instead of all, I think is the default, it will not write as many copies of the metadata, which will make it take fewer IOPS for every change you make to the database. Especially when you're making small changes like the 8K in Postgres, writing 3 sectors or 8 sectors, I think it ends up being worth of metadata, means that you're writing more metadata than data. And so reducing the amount of metadata will give you more IOPS to work with. And really, the downside to that is that you have fewer copies of the metadata if one of them is corrupt, but you're most likely using mirrors and such, and it's not going to be that big of a deal.
Yep. Okay, but this part is, I guess, we covered. You shouldn't overtune Postgres because yeah, you can make performance worse this way, but the thing that we mentioned are definitely improvements. So the second thing is that system diagnostics. Are there any tools in particular I should look into using from FreeBSD to explore why some of the drives, DA0 to 3, aren't addressable using gpart show? They show up in the output of current.disks and camp control dev list, and zpool status shows them as online, but when trying to boot, the kernel log starts complaining about the headers. After running gpart recover, these geoms just don't appear to exist anymore.
It depends. gpart show won't show anything if there's no partition table written. You'd have to have included your zpool status output for us to tell, but if you created the pool using the whole disk, instead of just using a partition, then ZFS will have overwritten part of the GPT table, and so there will be no partition table, so gpart show won't have anything to show. But because ZFS doesn't overwrite the first 16K of the disk to avoid stamping on boot code and so on, it might have left a little bit of GPT behind, but not enough to actually be useful, and that might be causing those kernel log messages. In which case, you probably meant to create the pool out of a partition off of each of those disks instead of the entire disk. Whoops, not a big deal. Except for when you're trying to actually boot off DA0, 1, 2, 3. But it sounds like you have a separate boot device, so you're okay.
Yeah, that shouldn't be too bothersome. The third part of the question is boot imports. The other 4 drives in the server make up a separate pool used for the host. Zabbix it's in its own jail and its own pool to separate I/O workloads based on the 15K and 10K SAS drives. This pool can be imported from an install USB, but not when trying to actually boot from the system or boot the system. I get some sort of message stating that it's unable to set an attribute U. Scrubbing the pool shows no errors, so I'm not sure what the problem is unless it's the physical drives, but then I'd expect issues trying to import the pool from an install image too.
I'm not sure where you're seeing that message or what it really means. I'd need more detail. And are you talking about importing it at boot or actually trying to boot off of it? I don't think you can boot off your Zabbix pool here because you didn't actually leave a partition for the boot code. So there's that. The way that the operating system knows to import additional pools beyond the one you actually boot off of is the /boot/ZFS/zpool.cache. So once you have the system booted and you have both pools imported, do zpool set cache file equals /boot/ZFS/zpool.cache space the pool name on each of the pools, and that will add them to the cache file. And that way, when you boot the system, it will try to import all the pools from the cache file that it knows about. And that's what would make the second pool be imported automatically when you boot off the boot pool.
Oh, yeah. That should be...
But, yeah, the attribute U or whatever message, it depends what part of the boot that's coming from. But it sounds like you're trying to boot directly off those drives, and they don't have boot code.
Yeah, that causes that error.
Or just your boot code might be too old. If you never updated the boot code after you maybe installed this box as FreeBSD 10 long ago, it might not be able to handle something in the newer ZFS, and you just have to do the gpart boot code stuff. But you want to make sure you actually write the right boot code to the right disks and the right partitions so you don't make a mess.
Yeah. And the message closes with, if all goes well, I'll be able to recover and get our system back up and running before the holidays. To revisit the issue with our production engineering team about getting some of or less frustrating hardware for this task when we return next week. But this is a fairly perplexing issue that I've not been able to dig up much information on. Thanks as always for the great show, and I can hardly wait for the conferences of 2019 to come around. Hopefully give a better prepared talk this time, at least at one location. Well, it wasn't so bad.
Yes,
and we look forward to it.
If you send the output of a bunch of the commands you ran, like zpool status, cam control dev list, etc.,
screenshots,
I can look a little closer.
But yeah, with our little tips, hopefully you could get a bit further and solve some of those issues. All right, that wraps up our episode for this week. Thanks for listening and watching. And as always, we'll have anything that you find in next week's episode. If you send it to us to feedback@bsdnow.tv, And yeah, see you next week.
Yep.